are you doing, Vishal?
Yeah, I'm good. How are you?
I'm good and glad to see you uh, back after a long, long time.
Yeah,
Great, great. All right. We'll just wait for a few more minutes for more people to join in, and then we will begin. Right?
okay.
All right. I think we have um, okay sufficient audience to start. I see I have Kopi joining in. I have Naveen, Satya, Sayan, Sujit, and Vishal. Great. Um, Welcome everyone, and I think this is great to see a few people coming in, and it's good that there are the audience is small, so that we could have a healthy conversation about what we are trying to do, and uh, have questions, discuss, and see how we can build, say, give on a given problem statement. So I hope all of you are comfortably sitting at your desk, preferably on your laptop. So as I had mentioned that this is something, this is in this session is something, and any future session what we wish to do. Just give me a second. Just give me a second. All right. So just one second. Just one second. I'll just need a minute. All right. I think we should begin. Sorry for that brief disturbance. So yeah, welcome everyone. As you would have seen on my LinkedIn post, what is this session all about? The session is firstly about problem solving, right? So be it any problem. Specifically, it is on data modeling, which is one of the essential skills when you are in the field of data analytics, data science, data engineering, whatever you call it. But the important thing is that we have studied about this a lot. I have been a CS graduate, and it's been 15 years now for me in the industry. But I could never understand this idea of data modeling at college. I didn't care either, right? But even after that, while I was working, most of the times I'd be doing SQL joins, SQL queries, group by aggregation. Who cares about data modeling? Why do you worry about that? As long as you're able to write good SQL code and able to serve your customers. But then as you grow, as you achieve a level where you are in charge of the database, and even on top of that, this was one of my life-changing experience when I joined a startup, and they were catering the agriculture industry of India. And I joined from a high profile uh, organization in top analytics company, Mu Sigma. And here I was in a startup with no database at all. So I used to take databases for granted, right? That, okay, there's a database and I have to query, and I'll be able to write complex queries and generate reports and all. But here there was no database at all, right? And they said, okay, design the database, and here is our front end application. It's going to send data, and then you need to save. I said, like, okay, how do we do that? They said, figure it out, right? So that's the response you get in startups. Nobody is there to sit and teach you and train you. Nobody has budget. And when I joined, the startup was already cash crunched. They said, figure it out. So all I had was Google, and I started thinking about, okay, what did I study in my college? What was those databases, normal forms? I don't know. I thought, okay, let's see how, what do we do? How do we proceed? So that's how it all started, and that's where I was forced to think about modeling. And then I understand the real value of, that's actually the first step. You have a blank database, it's blank, it's nothing. And how do you design so that the front end applications, whether it is from a website or whether it is from a mobile application, the data will come in and data will sit in comfortably into those tables. And then there is a nice prepared table for you as a business analyst or a BI guy or data scientist, or whatever, to take that data and do some crunching munching and develop reports or dashboards, or say some data science solutions. So the goal here is that how do we think? This first thing is about thinking, right? How do we think when we start about data modeling, right? How do we, instead of getting into jargons, I mentioned that there would be less of jargons, more about first principles thinking from scratch. How do we go about it? How do we even think about data modeling? How do we go about, say, designing, right? So let's start with the problem statement. And for the problem statement, I'd straight away go to the big school community website, and you can follow what we are doing on our website. You can, it's a completely open community, and we keep putting challenges in the domain of data. And we are working across data analytics, data engineering, data sciences, and all we post is small problems, and these problems help you think. So it's more about thinking, less about doing. If you can think about a solution in a very easy, in a very intuitive way, if you can design a solution in Excel, you can, I'm sure you can do that solution in the most complicated situations, like maybe Hadoop or Scala or Hive. Doesn't matter, right? Because in the end the fundamentals remain the same. So the problem which we are focusing on, the challenge which we are focusing on, is this one, right? How to model orders data better. So what is the situation? I'll skip the skills to demonstrate. There are a number of skills: normalization, cardinality, entity identification, candidate key identification, primary key, foreign key, blah, blah, blah. That's fine. So let's read the problem statement. I hope this is there for all of you. If not, I would say just spend 5 minutes just reading through the problem. All right. Just spend 5 minutes reading through the problem, and I'll also read. So you've joined this exciting new startup called Global Mart. Of course, it's a fictitious company, and this startup is trying to make its mark in the e-commerce sector, right? And you have joined in a very early stage. Like I joined that agri-tech startup, and you notice that the company is still dependent upon paper medium for taking customer orders. That's the very first stage. That, okay, you go to your customers, and there is this form, right? They fill up this form. They say, okay, this many orders which we are looking for. You take that form, and then you send that form to your warehouse, they look at that and okay, this product, this many items, this product, this many items, and they create an invoice, and this invoice is then sent to the customer. The customer pays for that after the receipt of the invoice. So there is a number of documents which are getting exchanged, right? So the role of IT is to bring digitization, to eliminate paperwork, and replace that with digital medium. The process remains the same. It's that the same process gets replaced by digital mediums. Like customer orders is now being exchanged via, say, a mobile app where the customer can fill in the order details, right? This information now needs to be sent because this customer is filling up, say, suppose a Google form, right? That could be the first step you could think about, say, uh, automating or digitizing the order taking process, right? You could think about, okay, how do I make the how do I eliminate this paper, right? So we think, okay, maybe let's design this order taking form on Google Forms. All right, so it's easy thing, anybody can do it. So you go and you design the Google form. So you mention that, okay, here you mention your name, customer details, what item and everything you mention, and the customers can start placing orders through Google Forms. That's great. What happens? We fill in the Google Forms, and this information it sits in what? A Google spreadsheet, correct? In Google spreadsheet, you'll have records, right? So each order which is being placed, it will have records, right? And then that spreadsheet is something which can be seen by our, say, inventory manager. That person can see, okay, this new order has come, this item, these many units, and this is the price, and this is the total sales order which has been created. So then that person will package that materials, say, generate an invoice that could still be on paper and send it to the customer. Customer receives the items, matches everything is fine, looks at the invoice, sends it to the finance team. Finance team sends the money, and money is received, so this entire transaction gets completed, right? So this is the challenge which we have as the part of the startup. That how do we digitize this core business process, right? The first is the order management process. This entire order management process will be inclusive of raising a purchase order, right? A customer order. That's the first thing. Then supply order form is raised. So for example, if you are say fetching your products from your vendor, so there will be a supply order form. Purchase order is being raised by the customer, right? Supply order form is raised by us itself. Then this invoice is raised by us and sent to the customer. Then there is a return order form which is raised by the customer and sent to us. So there are these different kind of forms which are being filled, and these documents are getting exchanged, and hence the products are getting exchanged, right? So let's look at the product purchase order form, right? So we have the company logo, the company name, the complete address of the company, the point of contact, the date, what is the purchase order number, the customer number, then where this needs to be billed to, where this needs to be shipped to, right? And then if there is a shipping method or shipping terms, that information is being placed here. Items are being placed, which is again the most important part. So item number, this is the description, this is the quantity, unit price, and total. And then some remarks, the subtotal, some discount. If there is anything, if after applying the discount, this is the total value. Then there's the tax being applied. So total tax is this much. Shipping and handling costs are applied. Other costs are applied, and the total amount which needs to be paid for this customer purchase order is $368. And then you have the authorized
Amit, if you are
signatory.
sharing something, we are not able to see.
Oops. I'm sorry. Yeah. So this is what I was talking about. So there's a purchase order form, right? And this is the form which is being sent by the customer after filling in all the information. So customer is putting in, this is the details of the customer, the name of the customer. Maybe say you are sending the products to Walmart, maybe. So Walmart is the customer name, the details of the customer, phone number, address, email address, point of contact, where to bill, where to ship, right? Customer number, dates, and anything related to shipping. This is something which you'll find in any bill which you receive when you're going for purchase. What are the items, descriptions, quantity, unit price, the total amount, and then the tax information, discounts, any shipping handling costs. So the total comes out to be around $368. Then there's authorized signatory, date, some concerns. So this is a typical purchase order form, right? And the goal is to design a solution for storing this information in your backend, right? So till now there hasn't been a backend. It's all paperwork. But now company wants to get digitized. And the first thing about digitization is to ensure how this information is going to be stored. So how is this information going to be captured? That could be a front-end application. Maybe a software developer developed a very nice app for you, right? And that app has all that company details and everything is there. The information is filled in. That information is sent to your server. And in that server, you have to ensure where will it sit, right? Similarly, if you look at the return order form, the return order form is also something similar, but here this is required by the customer, right, to file any return request. In case there is, suppose the items are more than what was required, or if there were damaged items. So all those items need to be returned. So if you see, here again the company information, then some steps is mentioned where the first thing is about which is the who is the provider. So provider name, the address details, what was the order number, on what date the order was placed and what date the order was delivered. Then about returns, that what are the items being returned, for what reason, what how many quantities being returned, what is the price. If you see, there is some return and refund policies have been mentioned, that okay, if the policy is according to this, then only it is going to be returned. Some comments and some information. So if you see, whatever is happening on paper now has to be designed so that it can now go and sit in a database. Let me just reset this one. All right. So what's the ask? Come up with a feasible data storage solution which should fulfill the below requirements. Data should not be lost in any transactions. No inconsistent data. Highest quality of data quality. Highest levels of data quality, which means no data duplication, no wrong data. So the ask for the challenge is suggest a suitable database to cater to the client needs. State the reasons why you went ahead with that choice. Design a robust data model to digitize the business. And I have provided link to draw.io. It's an excellent tool which you can use to decide, basically to draw various kind of diagrams. So I can just say create a new diagram, and I can just click on entity relationship diagrams, and I can say create. Let me check if there are templates. Hold on. Okay, that's fine. You can say create. I can just save it somewhere. PRD. All right. So this is something which you can use to draw a high quality ER diagrams, but I'm not jumping into it straight away. I'm not even going there. All we use is plain Excel to do this. All right. So what we'll be doing is we'll be going through this journey, right? To start with what is needed, and let's think intuitively. Okay, I'm not bringing any jargons here. Okay, all the jargons will come automatically, right? So let's start off. Let's get back to what is the ask, right? All right. So let's look at the order form. The order form has a number of information. Let me just simplify this first. Okay, so we have what are the information we have? We have the company information, which means I have so if I call that company as customer, so I have the customer name. All right. So suppose I'll try to design a data model, and when I say design a data model means a way to store the data. And the easiest way we know to store the data is in tabular format, right? In a table. Excel is a tabular format. So I need to capture company name, all right. And I need to capture company address, customer address, okay, address. I need to capture customer phone number, right? Okay, point of contact. This is going to be a person, customer POC, point of contact. Okay, so I have successfully captured this. So if I have, say, I'm capturing maybe say from a Google form, in the Google spreadsheet, it will look like this: customer name, customer address, customer phone number, customer point of contact. Great. What else can we capture? Then we have the date. Okay, so this is the date. So it could be the order date, right? So it could be the order date or purchase date. Great, I've captured that. How about order number? I can put that also. That's nice. Who's the customer number? Customer number I can also mention. Customer number. All right. And then bill to. Bill to is again an address. So I can mention bill to address. And then I can have ship to address. Okay. Bill to address, ship to address. What else? Um, then we have, let's keep aside the shipping method. Let's get into the items. Okay, so I need to put item number. So let's put item number and then put description, quantity, unit, and total. So this is quantity. All right, and this is the unit price. Unit price and total. I'm not mentioning because total is something which we can calculate. All right. So if I can capture, if you look at from the say if you're filling from say a mobile phone or maybe some from a web application, the customer is not going to provide this $100, right? They'll say 10 units I know, and this $10 price, this price is something which is already captured, right? It is already captured. So for the user, you will give that, okay, how much quantity you want, and this price actually needs to be displayed, right? That this is something I already have. I'll show that price, and based on that, the total will be calculated. All right. So I have done that. Now, a very simple model I have created where I have a table which is having all these different inputs, right? All these different inputs are there. Let me just highlight this in maybe yellow. Okay. A nice table. I can start filling in information. I'll get it. And then if you have some discount and all, so I think we'll have to put the discount, taxes. Okay, so that will decide the total value, right? Because you have a tax rate and then you have some shipping handling costs and some costs are there. Then signatory is there, date is there. That's fine. So let me just extend this to these two also. Oops, sorry. Let me just extend this to these two. So this could be a data model. So what we can do is we can say, hey, go ahead and create this table in your database, and you will be able to capture all the information which is there in your purchase order form, right? Nice, job done. Now this is where we have to start thinking. There are several challenges which can occur if we go with this. But again, as I said, that when you're thinking about an approach with the first principles, most commonsensical approach, this is what anybody can come up to. Okay, just create a flat table like this in Excel because that's the most accessible tool, and I can start capturing. But think about this. The first challenge we will face is we have 4 items in a given order, right? So if I am capturing information, all this information here, so suppose my customer name is Amit, okay, address is say Bangalore, and phone number is what something. The point of contact is say Rahul, okay. Order date is say 22/1, 11/1, 22, okay. Order number is something, and then customer number is something. bill to address is say Bangalore, and ship to address is suppose Mysore. Okay, item number 111, description is something, and quantity is 10, unit price is 10, discount is 2%, 0.02, and the taxes is suppose 10%, right? This is one record. But if you see here, this record, depending upon the number of items, I'll have to repeat this, which means when we are capturing this information, when we designed this table I'm assuming is going to capture an order, right? So if this has to capture an order, and for every item, if I say start capturing it like this. So since there are how many items? 4 items. So I'll be capturing like this. So this will be different, right? So with this, what's happening is this table which we have created is no longer representing orders at a given record level. If you look at this one, this is one record, right? If you talk about Excel or if you talk about database, this is a single record, right? And this record is not representing an order now. Why? Because if you look at the next record, here also it is the same order. If you look at this one, here also it is the same order. If you look at this one, here also it is the same order. So which means when I'm saying that every record should represent an order, what I am saying technically is that I want the each record to be uniquely representing an order. And whenever we talk about uniquely representing, what should hit in our head? Primary keys, right? So I'm thinking when I designed this table, I thought that I will design this table so that each record uniquely represents an order. But it so happened it could not, because and if I had just one item per order, then it would be okay. But I have 4 items per order. You could have thought about one more way. You could have thought about that, okay, this one is item, this could be item 1, and here I could have designed more columns, item 2, I for item 3, for item 4. But again, this would be a challenge. Why? Because there is no surety that how many items will be part of a given order. So if you see, I could have solved the problem of my one of the records, but this could now become an order level, because this order is having all the information which is associated with it of all the items. But if you think about the next order, which could be 112244, here it is possible that this order has just 2 items being ordered, right? Something like this, like this, right? I'm sorry, I do not need this one. I'll just take this one, right? So how about these 2 items, these two columns which I have created? This is going to be blank. All will be blank, right? So is this a feasible design? Of course not, because you never know. If you have 100 items in a given order, does that mean that this is one chunk of column, 1 2 3 4 5 6, 6 into 100, 600 columns? Will that be feasible? Not at all. That itself looks weird, that I'm already come to AG, right? This many columns. And since the number of items which I'm dealing with is not fixed, I am never sure that how many columns should I go with, which means you have to wait for that order in which the number of items is highest in order to create all the required columns. And then it will keep on changing. That's a ridiculous design, right? That by intuition itself looks wrong. That something doesn't look right. So what we did other than that, which is this one, is still a better design, because we have kept the number of columns to be fixed. And this is a restriction which comes with relational databases, that you will always when you design a table, you design a table beforehand. You model the table beforehand, before the data comes in. and the structure is not very flexible. If you want to change the structure, it takes a lot of effort, right? So whenever in your requirement you see the design is not requiring a lot of column changes, that's one of the reason you should think about going for a relational database. If your records they are suitable for a structured table storage, like in Excel. If you can store your information in Excel, you can safely think about, okay, let's go for relational database. That's a very, I would say, very rudimentary reason to think about it, but that's not all. Your decision can change. Okay, so right now what we see is that I am able to capture a given order as multiple records in an Excel sheet. I'm able to do that, right? So which means when you are capturing this, first takeaway that my order is my a single record in my table is no longer at an order level. What is at that level? It is at an order level and at an item level, because each record is now representing an item within an order, right? An item within an order. And whenever we think about saving information in a table, one important thing that you always think about is this level. And this level, this word level, is what we, the technical term for this level is granularity, right? What is uh, the information which you want to save? What is the most lowest level you can go to correctly save the information? We just tried out saving the information only at an order level, and we faced that problem of number of items keep switching. So we had to avoid that bad design. Now we are going down, right? Because for each item I'm having new record. So the granularity of this table, this storage, is at item level. Because when I say an item, that item is independently not does not mean anything. Because when I say item, I'm basically talking about a product. If I'm saying a mobile phone, right? My mobile phone, what I have, the same model thousands of people have. So I cannot just say that my data set, this data which I'm storing, is at an item level. Because if I say at an item level, I need to ensure that at an item level, this data set needs to be unique, right? Whenever I say something at a given level, I'm automatically saying that is the lowest level of granularity, which automatically says that now each record needs to I mean, that column needs to uniquely represent that record, which means I would like to have this one as the primary key. And primary key is the first important idea which relational databases, or be it any database in the world, which offers to you, because of this idea of uniqueness. Think about duplication. Think about somebody, think about Excel or Google Form. Google Form, same order, you can comfortably punch in twice. What will be the problem? Instead of $360, $68, the customer will get an invoice of 600 and something, 700 something dollars, right? Disaster. Customer will say, I'm not working with you. You're charging me double. Worst case, if somebody by mistake forgot that the person had placed the order yesterday, places it again, that customer was expecting 10 items, gets 30 items, right? Of no fault of anybody, because customer has got a Google form, customer fills it, and customer forgot. Anybody can forget. They can fill it again, and you get, okay, you feel that customer is requiring the same set of orders again. But that was a classic case of duplication. And that is one of the core reasons any database exists. It does not allow duplication. And that is why we need primary keys, right? That's why we need primary keys in a table. And Excel, Google spreadsheet does not guarantee that you will not be able to enter duplicate records. You can comfortably enter duplicate records. And that's where relational databases come in picture. They do not allow any duplication, right? They have lots of rules in place, and the rules in place are to ensure that the data quality is in check, right? So first thing is that whenever you are designing any table, have you identified what would be the granularity of your data, and After you have identified, the next would be to identify what would be your primary key. So now I would now let the audience also to come forward and help me design what would be the primary key of this table. How should be, or what should be the primary key of this table? How do we think about it? Just think intuitively. If you have a background, that's great, and that would be awesome. But if somebody, if you're even if you're new, give an attempt based on the discussion we just have had. We have to design a primary key here, because I need to now design this table in a relational database. So I need to decide what would be the primary key, right? Think about it, and let's discuss, according to you, what should be the primary key of this table.
Yes, so Amit, hi, this is Samir.
Yes, Samir.
Yes, so right now we are discussing that this particular table has data
Let me just switch off my video. There's a small problem, not able to hear you clearly. Yes, Samir, please go ahead again. Samir, I'm not able to hear you. Can you try again?
yeah, can you hear me now?
Yes, yes, please go ahead.
Say in the same table, if there is a data for me also, I am a customer, say Samir, and his
Mhm.
order, he has a specific order number, but the item numbers over there can be same what is mentioned over here.
Exactly, exactly. That's
So we
true.
cannot have item number as our primary key in that case.
True, true. That's a correct observation. And as I said, I have a mobile phone, a Samsung phone, and even Samir can have that same Samsung phone, right?
Yeah.
So I cannot keep that item ID as my primary key for this table. That's for sure, right? So that's item number is out of picture. Any more thoughts?
So, Amit, you decided on the entities, right? There will be different entities, correct?
I've not gone into there. We'll get into there.
Okay, so you just want to do it at the order detail level, basically.
Yes. So right now, so we have come up to this one. That okay, this is how we will store the information. That's what we have thought about right now.
Okay.
Okay. And now the first thing is that I need to ensure there's no duplicacy in the data, right? And relational databases will ensure that. But for that, when I design the table, I need to tell the database that hey, this is going to be the column which is going to be the primary key for you, right? So what would be that column is what the question is right now. It cannot be item number that we have just discussed.
So can it be more than one column?
Good thought. Who's this? Satya.
Satya, yeah, hi,
Yeah.
sorry.
Yeah.
So
So
what about order number and the item number?
yeah, that's correct. That's correct. Order number and item number together can make a unique order. Why? Because an item number, a mobile phone, in a given order number, if say someone also purchases the same mobile number, the order number will be different, right? So in any case, this combination of order number and item number can never be duplicated. True. There comes the idea of candidate keys, right? So when we have to decide that okay, which columns should come together, and I mean, when you think about okay, what should be primary key, most of the times we have in our head that there should be a single column, but no, it could be any combination of columns which could be candidates. Like hey, I want to become the primary key, I want to become the primary key. There could be multiple candidates. So primary keys can be created by keeping a single or more than one columns combined to make to ensure uniqueness in the data. And we know that we cannot use order number individually, we cannot use item number individually, but if we combine order number and item number, that will ensure that we have uniqueness in the data set. Here if you see in this one, this is surely wrong. Because why this is wrong, this one and this one? Because for a single item in an order, if there are more number of items, then it has to be decided by quantity. I will not enter this, I will not make this entry 10 times. I will just mention the quantity 10 in a given order. So this should be something like say 444, right? So that's the first thing. We can now identify very clearly that okay, just let's create a column here, and let's call this as say a primary key. All right, key, and key will be equals, I'll just say order number ampersand item number, done. This becomes a unique key, and this is something we can also call as the natural key. So there are two kind of keys which we create: a natural key and a surrogate key. Surrogate key, when in a database, when we create the surrogate key, is basically something. Just give me a second. Yeah, I just put myself. Yeah. So surrogate key is something which is you create in a database by automatically generating sequential numbers, right? So when you say yeah, if you remember in a SQL Server database, we use identity. I create an identity column that generates sequential numbers, right? And those sequential numbers are auto generated. They do not have any meaning. They just ensure that there will be uniqueness. But if I have the in my data, we have the order number. Where is that? Yeah. So here we have the customer number, we have the order number, this one, and we have the item number. So A246 A111, that becomes one key for one record, right? And this has a meaning because the order numbers which is shown to the customer, it has some meaning. It is based on some logic, maybe date, some short code of order, short code of company, short code of locality. All that is kind of combined together to make uniqueness. Like that barcode which we have in our food products, right? It has a meaning. You can actually break it down and extract more information. That's a natural key. But if I put a number like 112466749434, that's a surrogate key, which means it is something which is generated by the database, but you also need to have a natural key which will help, which will ensure that from the data perspective there is uniqueness, right? So we have taken care of that. Okay, now I can go ahead and create this table in the database, because now I have a primary key defined, and I have all these columns. There is next thing is about data types, that okay, the customer number, how long that should be, and customer address, what should be the data type, phone number, and all those things. We will go that later. Now we will talk about that. Okay, we have design. I think the problem is done. We are all good. Uh, so we are done with data modeling. Should that be a single table? Now let me talk about a bit about history. So the relational databases are the oldest form of databases. They, I mean, started off somewhere in 70s, and Oracle was the pioneer, and then SAP came in, and Microsoft came in, and then IBM came in. Hundreds of companies came in. They offered their own databases. Oracle offered its database. SAP has IBM DB2, Microsoft SQL Server, MySQL, right? PostgreSQL. These are all examples of relational databases. And in older days, one thing was luxury, that is space, the storage space. So whenever you say pick up, you wanted to save data, so and in those times these ERP softwares were in picture, right? So these ERP softwares were doing the same job, converting the paper based transactions to digital transactions. So the challenge came in, that okay, I could store the data like this in a flat form, which is like, okay, this is having everything. But now also look at what challenges it brings with itself. Considering older days, today that doesn't matter, but older days there was this problem of space. Space was a luxury, so whatever model you design, you should ensure that you take up minimum space in the storage, right? And let's look at this problem. So with this, what is changing in this entire table? What is changing most frequently? What will change is the item details, right? Because this is the information which will keep changing, right, most frequently. Then the next lesser frequency will be the change of order number. So suppose item number will change in every record, but order number will change after every new order is coming in. So now here you will say newer order number, right? And this can run suppose 10 times, whatever. So with order number, all the information about order will change, will be the same. So if order number is 112233, order date will remain the same for all the records. Shipping address, billing address, that will remain the same for all the records. And what will change the more, what will change the slowest? Slowest will be your customer information. And this customer information is going to change only where there is a new order from a new customer. So it could be like the same customer Amit places 10 orders. So, and every order has 10 items. So there will be 100 records with same information about Amit repeating, right? And this was a huge problem in those days. Today, you can say I can save in Excel, but those days the storage sizes were in MBs and all, right? So it was always a problem that this is lot of repetition. This is lot of data redundancy. So this redundancy need to be taken care of if I need to save space. So this was one of the problems where information is repeating a lot, and to tackle that repeat of information, something needs to be done, right? What we saw, item numbers will be the most frequently changing record, orders will be next slower, and then customer will be slowest. So the record, so the information which is changing the slowest, which is the customer record, that is something which is causing the highest redundancy. Order is also breaking redundancy, right? But customer is the biggest problem right now. And this is about just 4 records. Think about 4 million records or 400 million records, right? What's going to happen? It is taking up huge amount of space. Suppose one cell is 1 KB, right? So 1, 2, 3, 4, 5, 4. Okay, 4. Yeah. So this is 4 KB. This is 16 KB multiplied by 400 million. Think about, just think how much space it would have captured. And this was a pain point at that point of time. So the question was, how do we take care of it? How do we reduce redundancy? Redundancy was one of the problem. Second problem, if at any point of time customer said that, okay, I want to change my phone number is very important, right? Or email ID. Customer said, I want to change my phone number, email ID, and this request comes to you, and you are the database administrator. What will you do? You will run an update statement in this huge 400 million records table, and it's going to change everything. It's going to bring the system down because it's going to be slow. That's one. That's just one information. Customer wants every information to be changed, right? This becomes a problem. That's update anomaly. Then, if that customer wants all its information to be removed, the customer is no longer in the system. The information needs to be the customer. Say the customer placed orders, and the customer wants all the orders to be taken away. Right? It needs to be deleted because orders were wrong, and new orders need to be put in. What will I do as a database administrator? I will look at all the orders which belong to this customer Amit, and I will run a delete. What's going to happen? Everything goes off, right? The entire table is blank, gone. What did I do? Other than along with order records, I have taken away customer records also. So I just wanted to get rid of orders, I got rid of customers, right? That's deletion anomaly. All right. So, and if say for a given customer, say in information, I talked about information change, I talked about deletion. So these challenges that forced people to think that how do we solve this problem of space, and then these CRUD operations, this update, delete, right? If these are challenges, how do we take care of them? That's when came the idea of normalization. And with normalization comes the idea of entity. So there are two ideas which came in: normalization, and with normalization came the ideas of entities also. So how do we think about entities? So Vishal just talked about that. Okay, we should talk about entity. Yes, we should talk about entity, but why should we talk about entity? I just wanted to put a context there, and there's a clear historical context here. Why we need to start thinking this not just as a single table, and this single table, this is actually called as a denormalized table, right? It's called as a flat table or denormalized table. That's what it is called, right? What we are talking about is normalized table. And normalization is something a relational databases database is designed for. And I talked about this being the oldest database. So when it was designed, it was designed with the idea of with the taking care of the pain points of those days. All right. So now coming to entities, thinking very naturally, we are seeing that there is three kind of information: customer information, order information, item information. If I'm saying each record is unique, which means each record should be changing something. There should be something new in each record. Order is not ensuring that. Customer is not ensuring that. Customer is changing with only a new customer for a new order for a new item. And order is changing only for a new order for a new item. So it makes sense that let's take out orders and keep separately. Let's take out customers and keep them separately. And as we take out orders, as we take out customers, then we need to ensure that how these different blocks, they are related to each other. So when we think about entities, and it's a very natural business way of thinking. Let me just draw things. Okay, so let me just open my OneNote. Let me just open OneNote and let me just yeah. So here, let me just draw this thing. When we think about entity, so it's all about business. So think about your business, right? In my business, what are the parties? What happens? Which kind of business I am? I'm in the business of e-commerce. My job is to sell items, products. So what is that I'm selling? I'm selling product or item, right? So this becomes one entity. It's like people, place, or thing, which makes sense for the business. That's an entity. So product is an entity because that's the first thing I have. I have a product I want to sell. How do you sell? I sell to customers. So customers also matter for my business. So hence customers also become an entity. How do customers purchase these products? Customers place orders. Orders also become an entity. For a given product, is it that I am selling or I am sourcing that product from my vendors? So vendors provide products. So vendors become another entity. So the simple way to think about entity is that these are the different parties in your business, different parties or products or things or locations, whatever, which are relevant to your business, which makes sense for your business. If you take out customers, there is a gap in the business. Your business cannot run. Take away orders, can't. Take away products, definitely not. Right? So simple way of understanding entities would be that all those parties which make your business successful are your entities. This is also called as business objects. Business objects, right? And once we have this kind of a diagram, what we do is think about how in real world this will happen, right? So customers place orders, right? Customers will place orders. So when they place orders, in the orders, choose products or add products. Vendors supply products, right? So what I'm in this diagram, what I'm trying to show is I'm showing that how one entity is related to another entity. It could be that a given entity is not related to. For example, vendors and orders may not be directly related because vendors are not at all concerned with orders placing, because orders placing is happening via customers. So in a given order, you need to have who placed the order and what items were purchased. So order has a relationship with product and customer. But when you think about vendor, vendor has a relationship with product because vendor is the one which is supplying the product to us, or vendor is supplying the raw material to create that product. It could be that way. So entity identification is one of the skills which will happen when you understand the business you are in a little bit more. If you are an insurance business, you have to again think about what would be the parties, people, places, thing. So in an insurance business, customers is again always customer is going to be an entity for sure. In insurance business, what do customers do? Customer file claims. So instead of orders, you'll have claims, right? Customers file claims, and customer purchase policy. So instead of order, policies will become another entity, right? And then there could be few more things, like there's a policy, there is claims, right? There is customers. There also there could be vendors, or there could be, say, TPA, third party approvers, right? So TPA in insurance business, that is another entity. So entity identification is purely a business task. So somebody who's a business analyst or aspires to be a business analyst, and it will definitely come with practice. There is no fixed formula for identifying what would be the entity. But once the entity is identified, the task becomes simple, and normalization will start making sense now, right? So we see that clearly in the data. There is a set of customer information which is till this one. Let me just color the columns. Let me just color these columns, and put them as, say, blue. And then there is order information. This customer number will also go with this one. Then we have, suppose, order. Oh, let me put this in a different color. So I'm just intuitively putting, let me place, let me cut this here, and let me paste this here. Okay, so all the customer information is staying together, all the order information is staying together, and all the item information is staying together, right? All the item information is staying together, so that is yellow. So there is clearly three entities here: order, customer, and item. So what we will do is, let's take all the customers out. And let's take all the customers out. So let me go to a new sheet, and here let me just transpose this. And what I have is, let me just clear the color. All what I have now is a customer table. This is my customer table. Now, when I took this information out, I naturally picked up all the records which are repeating together. So customer means customer. If customer name repeats, customer address will also repeat. Customer phone will also repeat. POC and customer number will also repeat. I did not take order with me, because first of all, order is a different entity, and the frequency of change of order is also different. So let's take this out separately. Let's take this out separately, and let's keep them here. And this would be my orders table, right? And then finally, I have my items. Let's take items separately, and I'll place it here. Change this one, this one, this one, and let's call this as items. All right, done. We have now separated out, and in a very, I would say, crude way, I have achieved normalization. And when I say I've achieved normalization, means I have broken the table. And I've broken the table by keeping a simple logic that all columns or all attributes which make sense together should be together. All attributes which make sense together should be together. That's exactly what second normal form says. Okay, I've not talked about the first normal form, right? But I'm straight away talking about the second normal form. Okay, first normal form has a small change which we'll talk about. Uh, the second normal form, it says that there need not be a partial dependency and something. Let me just open a very nice reference, which I have really enjoyed learning from. This is from this channel called Study Tonight. They have done a phenomenal job at creating some very good learning material on normal forms. I'll show his website. So very nicely written about problems with normalization, with app example. They talked about insertion anomaly. They talked about updation anomaly, deletion anomaly. We just talked about. And here he starts talking about first normal form, second normal form, third normal form, BCNF, fourth normal form. I don't even know what this is and how this works. I don't even know correctly. I didn't even get a chance to apply BCNF somewhere. But these three are something which is definitely something which I got a chance to apply on. And in 90% of the cases, this just nicely works. But it's just that we're going to make sense of it. That, okay, instead of straight away without going to understanding what's the rule and how does it work, what does it mean? If I now look at this one, second normal form says that it should be the first normal form and it should not have any partial dependency, right? Partial dependency is something like this. This is what was partial dependency. That with customer, is address changing with customer? If customer changes, will address change? Yes. If customer change, will order will say customer phone number will change? Yes. Right. Customer POC, will it change? Yes. Customer number, will it change? So all the attributes which are in sync is like wherever you go, our network follows, something like that. Okay. If you change, I'll also change. So all the related information or attributes, they should be together. And when we talk about partial dependency, so let's talk about this column which we created in the order and item. So we are clear that these are all which should go with customers. So we have sent them with customers. So customer is separated out. With that, what is the gain? What is the advantage we are getting? We are having a table with one record for each customer. So the granularity is now for this table is at customer level. Again, whenever I'm creating a new table, I need to ensure that what is the granularity and which one should be the primary key, right? So we know that customer address is a globally identifiable unique number, right? Unique value, or customer phone number. Customer phone number or customer address will be unique, right? They can never be different for same for two people. So customer email address, instead of this one, I'm just calling a customer email address, which we did not have. So this email, this could become a primary key for this table, and this one will be the natural key, right? But for the database, to ensure there is an integer, and I'll talk about why you should keep a surrogate key in your database, I will be entering something called as the customer ID. And this customer ID is not generated by the data, it is generated by the database, right? So it is a number which is going to change as new record gets entered to ensure that your database is always unique. But your natural key in this case is email, and customer ID is a uniquely uniquely generated key. Similarly, orders, when you go for orders, so now you have one record per customer. If you need to change any customer, say any information about customer, how many records you have to change? Just one, right? So if the customer if the customer order has is to be deleted, customer orders can be deleted, but customer still remains. So I know that, say customer name Amit had 100 records, they had problems, those orders have been removed, but the customer remains. So deletion anomaly is taken care of, update anomaly is also taken care of. And the biggest pain point, which was, say, space is taken care of, right? So now what is happening is, these many 5 columns get replaced by just a single column, and that column would be just a reference column, and that reference column is going to be customer ID, which is going to point to the customer ID here. So which means in customer ID, I have to enter in order table, I have to enter a customer ID reference column. And why do we need references? Because without reference, how do I know which order is for which customer? At a reference, that's why I have replaced 5 columns with one column. So 5 GB with 1 GB. So space is saved, right? But it's like nothing is best, right? If I address a problem, new problem will come. What is the new problem? I need to ensure there is relationship between this table and this table, right? So there needs to be relationship, and this is some logic. There is some logic written when I actually write that, okay, in this table this is the primary key, and this one is a foreign key reference which is pointing to this table and this key, right? If I do not provide that, if I do not provide this, there will be problem. What will be the problem? That if I say, in this case, I remove this customer, right? I remove this customer, that, okay, this customer is no longer in the system. But since there is no relation, this customer ID will still exist. And this is the problem of ghost records, right? What will happen? I can remove this customer, comfortably I can remove it. But this customer ID 101, all the orders for this customer 101 still exists in this table. And this relation, or what we call as referential integrity constraint ensures that if you are doing something like this, first the child records need to be removed, then only the parent records need to be removed. What we understand from the cascade, this one, when we write a table, we also mentioned delete cascade or drop cascade when you have to remove any records, right? Which means it will check which are the child tables in which customer is still available in. So all those child tables, first the customer information needs to be removed, then in the parent will be removed. This ensures integrity in your data. Integrity is a quality problem. If I do not ensure there is a relationship, this kind of problem of ghost records will happen. And hence, we have to ensure that if you are separating out the table, please bring in a referential integrity constraint. Same thing will happen when you go with items. In items, because item has been separated out from orders, I'll have to keep an order ID. Order ID. I will say, okay, I have kept an item. What would be the uniqueness? We know you talked about that. Okay, for item, this one, a combination of item ID, this one, order ID and item ID, that should be the primary key. That you can always do. That you can create a natural key by combining those two columns. It was like what? This you can call it as item ID. Okay,
But
item
Amit,
yes.
item will not be dependent on order, right?
True, true,
I mean,
true.
order is dependent on item.
uh, uh, Order, see, when I'm creating here, I'm concatenating the two and I'm creating like an item sequence or something, some
Okay.
item say number.
Mhm.
And then I will also use the identity to just generate a unique key. That I will call as item ID. This will be the surrogate key for the table, which is again just ensuring that this natural key which you created as a combination of item ID and order ID, that has a surrogate key in your system, which you can which is important for the database, and I'll tell why. Okay. um, Surrogate key is very simple. Why do you need surrogate key? Surrogate key are integers. And why integers? Because integers are fastest for search. When you're doing a search in a database, if I am searching on, say, customer email ID, which means email ID is textual, and a text is a combination of characters, characters need to be represented as integer internally, then your search will happen. Because if you think about databases, binary search is what happens by default. If I'm doing a search, so it will look for the middlemost item, and then it will look for whether the item record which you're looking for is on the left or the right. Then it chucks out the not required section. Then again looks for the middle point. That's the binary search, how it happens. So that will happen fastest when you have your primary column represented as pure number. If it is not, it will become slow. So surrogate key is something which is not mandatory. You need not have surrogate key. I could have said that item number, comma, order number, that is the primary key, which is fine. But then the problem will be there are two columns which I have said should be the candidate keys. Instead, it will always be better that let's combine them. If by combining both of them, they are still number, that can itself be the primary.
So Amit, actually, so your column I is actually order detail. It's not only item actually.
Where,
What you
where,
meant
where?
to say is order detail, right? Your column I, this
Ah,
entity what you're representing,
ah,
it's when you say items, it's you mean to say the order items,
order item. That's true.
not item as an entity on its own, right? Because
Exactly.
entity
Exactly.
on its own will be item number and item description.
Basically, I think
Yeah.
I think this will ensure this will be correct now.
Like
Line
order
item,
detail actually. Yeah, line.
right?
Yeah, order
Line
line.
item,
Hmm.
right? So this one, because if I say line item here, what you are saying is a product table. Okay, this one will be mapped to say a product ID, product name, and everything. And when I'm creating a line item, I can have references to order ID. That is okay. This product
Right,
and a
right, got
product
you.
ID,
Yes.
right? So in this case, basically what I'm doing is I'm normalizing it even more. I'm saying that okay, the product details, let's not keep here, let's take out as a product table, which is a master table. So just like customer is a master table, even product will be a master table. So this table is basically going to be a line item ID. We'll have a line item ID, which is going to be a surrogate key which is generated, and it will have two foreign key references, one with the order ID, which will go like this, and one will be the product ID, which will go like this. So this table, we have tried to normalize it further, so we can keep all product information together. And this is like what do you call it, as multi-mapping. So it is mapping to orders also, it is mapping to product also. Vishal, that's fine.
Yes, correct. Yeah.
Cool, perfect. So if you see, we have nicely separated out the tables which were not related. Not, I would say, no. We have separated the information where attributes go together. Couple of problems which we still have in our data. If we look at our information again, look at the description. The description shows woman's tall M, men's tall M, children's S, men's XL. What is happening here is in the description column, and that will now come into the product table, which is here. Description will not be part of the product table. This description is not atomic. This column is not atomic. Atomic means it should represent one piece of information. You just talk, either you talk about, say, the description being woman's tall or something. This is the size. M is the size. So when you are keeping this complete information, nothing wrong. So again, when you talk about first normal form, we say that every piece of information in a column needs to be atomic. But if you look at the modern ways of data processing, many times this rule is kind of ignored. It's okay. What's the problem? What I'll do is I'll fetch this data, and maybe I'll do a strip in Python, right? Or in SQL also, I can strip the given column. I can separate out M and I can separate out this part. But then there is a trade-off, right? Either at the storage time itself you store separately, or at the query time you pick it up, and for every column you keep chunking. So there is a challenge on both sides. What first normal form says, that this is not how you should be storing. You should, the description, if it is it should be atomic. So you just keep woman's tall here, because M is a size. Keep size as a separate column. Here you store this could have values like M, S, XL, XXL, whatever. So then you have a separate column of size, right? And that is something, that's what ensures that now you are in first normal form, right? First normal form is pretty simple. It says that look at all the columns. If you can make them more and more atomic, try to make columns more and more atomic. There will be another case where I think we can try out ensuring a better design by converting to first normal form. Can you help me identify which column in which column I should be trying out for going for better first normal form among these tables? We have all these number of tables. Which column I should be trying for converting to first normal form? I've just taken care of the description. Just have a look at the columns, or if I can also bring up the design here. So I have the company name and address, and if I look at here also you have customer address. And you think about address is a combination of lot of things, right? And let's say think about how a better way of writing address. Better way of writing address would be like line number 1, or say address part 1, part 2, city, state, pin number, right? So a given address is again can be broken down into multiple components. So if I just say customer address, it's a pain point, because address can be written like anything. Anybody can have any format of writing customer. Like this is the street, this is the city, this is the state, this is the pin code, this is the phone number, right? Phone number is already separate out. This is the pin code. If I just ask people that we keep writing address, there will not be any format. If there is no format, we will have a problem, because if somebody says in my analysis, somebody says that give me state-wise count of customers, what we'll have to do, we'll have to get to the customer address column, some sort of string processing we'll have to do to fetch out the states, and then that is going to be hell of an activity. You will say data has been modeled wrongly. That's not correct the best way you have modeled. So you need to further normalize your data model to ensure that when the analysis happens, you have lesser and lesser load on the analysts. Otherwise, I could have just dumped my table just like our first way of doing it, and I could have done my job is done as a data modeler. But no, it's not. So we have to always think the pain point of consumption of data, because dumping the data is easy. But when you think about consumption, that's the real value of analytics comes in, right? So which means, first of all, this customer address needs to be taken care of. So I just go ahead and let me highlight this one. So we are going to focus on address. But if you see, we don't have just this address. We also have this address. We also have this address. Address is kind of spread out. In orders, you have address. In customer, you have address. You can have a supplier table. Supplier table can have an address, right? So if you see, the address is spread out. Different tables have addresses, right? So the first thing is that, again, whenever you see that attributes which should stay together, which can stay together, should stay together, right? So first thing is customer address need to be further normalized, right? So and second, um, can we design the table better so that addresses stay at a single place, and whoever want to refer to that address can do that. That's where we design another table, which is location table or address table or whatever. So generally, location is a table which will have all the addresses. So address can be for a customer, address can be for a vendor, address can be for, say, supplier, warehouse, address can be any address. Address is an address. Address can be for that company main office. Address can be for that company stores. So this one can have, again, we can have, say, location ID. Okay, then say address line 1, address line 2, then I can have city, then I can have state. Okay, state, then I can have zip code, right? And if you have to think about what would be the natural key in a given for a given say address, zip code would be a natural key, because zip code doesn't for two say when we talk about an address can have a zip code. But yeah, we can also think about that. Can zip code be really a natural key? It may not be, because two, say, in the place where I'm staying, another person who's staying next door, that person will also be in the same zip code. So zip code cannot be taken as a natural key. Then we could think about, okay, what else, right? What else could be say a natural key for this one? So what would be the, okay, I can take the lat long, I can combine the lat long, okay, because now I can have lat, I can have long. So these coordinates I can have. Can I say combine lat long and make that as a primary key? I think that will work. But then again, there is a risk involved there, that what if the, say, the geo maps which is capturing the address for me and the person next door, it just gives the same lat long. It may happen. So I can never be sure whether I can have a very pinpointed say natural key here. So then I just give a surrogate key, that this is the key which will act both like a this is going to be the only key which I'll be referring to. And what I'll do is, for rest of the tables, I'll mention location ID as the foreign key reference, and that will again be connected as a referential with a referential integrity constraint. So here you will have, again, build to reference ID, build to a location ID, and this could be ship to location ID, right? What did we do? How does this help? First of all addresses are at a single place. Second, the addresses are now more standardized. And this will force the front-end developer that when you ask for address from the customer, city, state, that will be a drop-down, right? Somebody writes Gujarat, Gujarat. Somebody writes Gujarat, Gujarat. That becomes a mess. That leads to a bad data quality problem, right? So list of cities needs to be provided as drop down. State should be provided as drop down. Zip code, maybe you can provide as drop down, or maybe you can let people type it out. So the point is, when we model the data, we should ensure that our model should force the designers, the front end designers, the developers, to ensure that neat and clean data comes and sits. That's the first need, that's the first requirement for a data modeler. And second, on the consumption side, both on the collection side as well as on the consumption side. On the consumption side, if the analyst, that analyst should be doing least grunt work to extract the data they want. And that's why address, if I store like this, if somebody wants to do group by say states, it's a simple, you take this one, can join with customer table, group by, do a count, done. It's a simple SQL query to be written by the analyst. Otherwise, this would have made the life of analyst hell, right? In address, I have to extract this. Names are not correct. There's so many problems out there. It becomes a problem. It becomes a pain point. And that's where your data modeler comes to the picture. And the data modeler does this job of identifying the entities, then identifying all items which need to be stayed together. And then as we are separating out, creating references, ensuring there is a relation, because even if we create tables, we need to ensure that, okay, this table has a foreign key constraint. And that's why relational database is something which is great in this case for choosing, because relational databases are the only ones which ensure there are referential integrity constraints. If you pick up a MongoDB, which is a NoSQL DB, it cannot ensure that. That you will have to ensure in your code, in your application code. But relational databases, they ensure that the data which comes in goes through a lot of checks. And that's where you have primary key constraint, referential integrity constraint, check constraint. Your check constraint is for value, right? Default constraint, if you want to keep any value as default. So there are these constraints which ensure that the data which comes and sits is clean, right? And by normalizing is a process, as we discussed, to ensure clean data ingestion, clean data consumption. But should you go do normalization? How much normalization should we be doing? Somebody may say that, hey, you should not have used location here. I am good with whatever customer order and line item. That's a degree of normalization. Somebody can say, hey, size, why have you kept size here? Keep a separate size table and keep a size ID here. Possible. But should I do it? Just for one column, should I create another? Because the more I normalize, the more relations I have to establish. The more relations I have to establish, the more constraints will come. The more constraints will come, the slower will be our joins, because I have to do a table A, join table B, join table C. That's going to slow down the system, right? So there's always a tussle between this, which is one extreme form, and this, which is the other extreme form. So there's always a tussle between normalizing and denormalizing. Where should I stop? And again, that will come with experience. But when we think about data modeling, this is how we start. And again, there are lots of things when you go for the next in line would be that, okay, I've just designed this, but how about the data types? What data type should I choose so that the data which is being stored in my disk is optimized? Should I look for varchar 1000? While my, how do I decide when my a given column has a lot of characters or less characters? What should I do, right? But for today's session, I think this is where we would stop. And the idea was to just take a problem and intuitively see that how and why we should think about normalization. And one thing just to close, that as we are defining these relationships, we also talk about the cardinality of the relationship, right? So which means that for a given order, customers can repeat many times. So this is 1:n cardinality, right? For a given this one line item table, there could be multiple orders, right? Again, this is 1:n. This is again so a product can a given product can happen in multiple places, right? So again, so this cardinality is something which comes along with while we establish the relationship. That's what we say 1:n relationship, 1:1 relationship, m:2n relationship. Those are the things which we talk about. All right. So that is it about the session today. Um, let's pause here, and I would like to take any questions from the audience out there. Any inputs you have, any thoughts you would like to share about the process, what I have followed, any inputs you would like to have, I would be very happy to understand that. Just give me a second. Just one second.
Yeah, great session, Amit.
Thank you, Vishal. Just give me a second. There's one. Uh, just a second. Mm. So what we are going to do is again. So we will continue to have such sessions where we'll just pick up a scenario, and we keep publishing a lot of such challenges on different topics, and the goal is again to build things together. Okay, so today it has been where I have been doing a lot of talking, but I really appreciate that a number of you came back and participated in the discussion, which is very heartening. So we are going to follow the same kind of methodology in our even our future sessions. So I would definitely invite all of you to come forward and have a look at our challenges which have been put, uh, and and then please feel free to contribute and spread across the message about what we are trying to do at Mentor School. If you like our work, um, we also I let me just share my screen actually. Just give me a second. I'm just going to share my screen. Hold on. Yeah. Oops. One second. Just a second. Thank you, Gopi. I really liked your comment. Yes, definitely. This is the whole idea, and as I said, it's always going to be based on first principles thinking, that why something should happen if something is happening, rather than, because if it is about concepts, I have hundreds of links which I can share with you, and you can learn from there. But when it comes to real world solving real world problem challenges, most of the times learning things, they become references rather than a points to start with. So yeah, I just wanted to share my screen and just talk about a bit about the community. So again, Mentor School is an open community, and it's all about hitting the problems head on. That's the philosophy. And we don't do any courses. What we do is we design lot of problems, challenges. It's all inspired from real life scenarios, what I have faced in my life, what many of our mentors, if you look at, there are several mentors which are part of the community, and they all belong to different domains. There is a senior data scientist, there is a BI lead, there's a big data architect, and we just connect with people. We talk about what experiences they had. Please share some great problems, and we convert those problems to challenges like these, right? If you see, there's a Power BI challenge. This is the challenge we talked about. There is a statistics challenge, right? There is a machine learning on cloud challenge. So there are a number of challenges. There is a simple statistic. There's an Excel challenge. There's an Excel challenge, if you see. So all these challenges we keep putting up, and we invite people that wherever you're free, give it a try. And the philosophy is help you think more. Why? Oh, I know what happened. Yeah, this is what I was talking about. So, yeah. So on our website, just go to our website, just have a look what all we are trying to do, right? It's an open place. Anybody can come in. If you want to contribute, if you have in with your experience, if you have any challenge, if you think that this is the problem I faced, I solved it, and you feel really happy about it, and you want to share that problem with the world, feel free to join our community. It's a Slack community. Pratik, if you can post that link also, you can join, and I'll be more than happy that you contribute, you help anybody out there. And if you're really, really good at what you are, your work, you can always opt for mentoring people. And there will be people who have actually started as a mentee, who started with knowing nothing, and they are at a stage in the community, they are now mentoring others. So that's one of the most heartening experience which I had, and that always motivates me to continue this community. So most welcome, all of you. Thanks for joining on Saturday, on a Saturday afternoon. Very happy, and yeah, stay connected. And if needed, please promote Mentor School as much as possible on LinkedIn. And thanks a lot for your time. Take care, and bye for now.
Thank you.
Thank you so much, Amit. Thank you.
Thank you. Gopi, actually, I'm not sure the recording won't be available. This was just a live session. Yeah, so it won't be available. Thank you. Take care. Bye. Oh, it's there? Okay, awesome. Then we can do it. Price can't be an entity. That's a good question, Sujit. When you talk about price, price will always be a part of something, right? When you say attributes which should be together, should go together. So what are those attributes? So price is an attribute for a product, right? So price can, again, this again becomes a question that, okay, should I separate out prices? Because think about it, price can always be changing, right? So this price point for a product, so if the price point is the same, it can still be associated with the product, and that can be, that you need not think about entity. But I have seen a scenario where price becomes an entity because we are now talking about price history, right? So for a given product, there could be multiple snapshots of price because price keeps on changing. So then price history becomes a separate table because the granularity is now changing. There will be price history ID or something, and that is going to be associated with the product. And in that scenario, I think you can have price as an entity. Sujit, right? Sujit, does that answer your question partially? Awesome, awesome. Great team. Thanks a lot. Go and have your lunch, and do promote us on LinkedIn. Thanks a lot for your time. Take care, and bye for now. YouTube channel, you can just check the website. There we have about our YouTube. Just type Mentor School, you will just find it out. So just go to YouTube. Thankfully, our name is unique here. So if you just type Mentor School, you'll just land up on our YouTube channel also. This is what we have. This is our channel. You can just go ahead and subscribe to that. Right? Let me put up the link here. Right? Cool. Any more questions, anyone? We'll be happy to address. All right. Take care. Bye, Vishal. Thanks again for joining. I really appreciate you have been part of most of our sessions, and again, very happy to have you here.
Yeah, thank you, Amit, for accepting.
Thank you. Take care. Bye for now.
Bye.
Bye.